All right. I'm going to kind of just do some thinking about reference angles. Reference angles was the first thing we did when we were talking about degrees and circles and rotations, where some of you were like, wait a second, this is really hard all of a sudden. Hopefully, we already did the test on reference angles. Hopefully at this point you feel relatively confident, welcome back, about reference angles. But if you don't, obviously Radians reference angles are going to be only more complicated. So here is the degrees. Again, it's not really on your paper. This is more like on the back if you want to write this down. Now, reference angles, okay? The way reference angles work, super important, is that they are always less than 90 degrees if we're in degree mode. Pick this up. And in the first quadrant, let's say we had something like 50 degrees. That was very easy because is 50 degrees less than 90? Yeah, sweet. And so in the first quadrant, that was super, super easy. If you remember, we made quadrant 1. You basically just keep it the same, right? We made this little table kind of thing over here. That's a really ugly one. Then we had quadrant 2. Does anybody remember the rule for quadrant 2? Nice, very smart. Because let's say you're over here, something like 120 degrees. We need to make a right angle, and we always connect to the x-axis. That means we always do our math with the 0 or 180 or 360. You never do math with 90. You never do math with 270. And so you guys are correct. It would be 180 minus angle. And then in quadrant 3, does anybody remember?
180 plus.
Angle minus 180.
There it is. Because if we did 180 plus the angle, that would be bigger than 90, surely. So, nice job. A couple people had that card. Nice job there. Angle minus 180. And the last one, quadrant 4, we're dealing with big angles, like maybe 300. Anybody remember the rule for quadrant 4?
360 minus angle.
Okay, we're actually so good. Nice job. I'm very impressed. It would be 3. Let's say we had something like 290 degrees. Yeah. We're going to make this triangle with the x-axis, and it's going to be 360 minus 290, and it's going to be 70. That's our reference angle for 290. Okay, it's not the same as coterminal. You're not adding and subtracting 360 a whole bunch of times. It's something totally different. It has to be less than 90 degrees. Okay. Now let's kind of take that and see if we can bring it into radians, where things are maybe a little bit less comfortable, maybe a little bit less straightforward. Let me zoom in a little bit more. Let's see what we're working with here. Wait. Okay. Reference angles. Let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle formed by the blank and the blank. Now, I'm not too fussed about getting this exactly what they want us to write here, but this is going to be the terminal side, basically just meaning wherever that angle terminated or ended. So for example, right there, that's the terminal side. And then if I'm going to make a triangle for my reference angle, here's the terminal side, and what other side do I use? The x-axis. Again, the whole point of that is just making sure we're not using the y-axis. We're not using the 90s. We're not using the 270s. It's all 180s and 360s. Now, the issue is that when we're doing this math with radians, we've got fractions, we've got pies, we've got those kind of things. Now, One way you can kind of do this is to set up the exact same table that we had before. And we're gonna kind of, I have it laid out a little bit different here. So first of all, worth pointing out, wait a second, let me make this box up. Worth pointing out that this is quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4. So,
Like the problem.
you see this? Quadrant 1,
Oh,
quadrant 2,
okay.
quadrant 3, quadrant 4, right?
Okay.
So, the rule for degree mode in quadrant 1 is leave it the same. The rule for quadrant 1 in radians mode is the same thing. Leave it the same. Don't mess with it. This question says pi fourths, so our reference angle would be pi fourths. I'll zoom in a little bit more. Now in quadrant 2, in degree mode, it was 180 minus angle. But in radian mode, it's not going to work for us. Again, if you get to a quiz or a test, you know how to do conversions. And so if you needed to, you could convert this into degrees, use your degree rule, then convert it back into radians. But like we talked about, you don't want to do that for every single question on a test. So how can we take this 180 minus angle and turn it into radians? 180, what is the radian form of 180? Pi. Pi minus angle. So there you go. We need to do pi minus the angle. And for this time, you know, obviously the angle is going to be a fraction. And just like, very similar to coterminal, when we go to set that up, pi minus 3 pi fourths, we're not really able to do it yet. When we go to set this up, when we want to add or subtract fractions, you can't. You need to have common denominators. Now, when we did coterminal angles, we always were adding or subtracting 2 pi. And so we kept the bottom the same, and then we doubled the top. You guys remember that lesson from yesterday? Today, we're not doing 2 pi anymore. We're just doing a single pi for this quadrant. So, I need to have common denominators like a 4. What is the top going to be? 4. Just a 4. We're not doing 2 pi anymore. We're just doing 1 pi. So it's 4 and 4. And now what's 4 minus 3? 4 minus, because look, we got 4 minus 3, which is 1. So we're going to have 1 pi divided by 4. I feel like this is a lot of weird symbols, and I don't know that the notes are organized in the best way ever, but let's just move on. C number 2, we'll do a little faster. This one was angle minus 180 when we did it in degree mode. So now that we're in radian mode, it's going to be angle minus pi. So let's look at our angle here. 5 pi fourths, subtract a pi. But let's go ahead and inflate that so that it matches. What number is going to go on the bottom? 4. And what number is going to go on the top? 4. Right, still a 4, also a 4. And what's 5 minus 4? 1. And so our reference angle is going to be 1 pi fourths. Yeah. And so then this last one, it was 360 minus the angle. So now it's going to be 2 pi minus the angle. So now, skills from yesterday, that double numerator is going to have to come back. 7 pi fourths, 2 pi minus that. But don't actually put a 2 pi. We want to put a 4 with an 8. And then what's 8 minus 7? 1. 1 pi fourths. Now, basically, what have we learned? Nothing really. It's the same exact formula as it was for degrees. we just replaced 180s with pies. We already know that. We just replaced 2 pies with 360, or I guess backwards, 360 with 2 pies. We already know that. And this skill of making matching denominators, we already know that. We did that yesterday. So we're going to do a couple more questions here, and it should go pretty quick. To start, we've got 5 pi 6. Now, before we figure out which rule to use, we got to figure out which quadrant is 5 pi 6 in. This is a skill we talked about a little bit yesterday before the quiz. If we're talking about 6s, you can do this. 0, 6, 12, because that would be 6, and that would be 12, and that would be 18, and that would be 24. But of course, all we need to do is get to 5, which is right here. Is everybody comfortable with how I got to that second quadrant?
Yes.
So basically, I see a couple heads shaking in the audience. So check this out really quick. This is 0, just like 0. And this over here is going to be 180, or pi. And since we're dividing by 6, I'm looking in the denominator and I'm seeing 6. This would be 6 out of 6, because that would be 1 pi. And over here, this would be 12 out of 6, because that would be 2 pi. And so then I see the numerator, which is a 5, and I say, okay, 5 out of 6 is a little bit short of 6 out of 6. So that's how I do all this work. It's not really that much work. And I realize I need to be quadrant 2. Sweet. That tells me to use my rule for quadrant 2, which is 180 minus angle, but I'm in radians, so I need pi minus the angle. And the angle is 5 pi 6. So when I set this up, I'm going to go for 5 pi 6. And instead of pi, I'm going to put 6 pi 6. Because it's just 1 pi, so the same denominator, the same numerator, 6, 6. And the final answer here is going to be, anybody get it?
Pi 6.
Yep, pi over 6. Do you have to put 1 pi over 6? No. You can just put the stylish pi 6. That's fine. Figure out your quadrant, do your little rule, be done. Move on. B. Which quadrant am I in with 13 pi 11ths? 3. Nice job. I need to be in quadrant 3. If you want a shortcut to maybe not think quite as hard, I know that this right here is 1, which is when the top and the bottom of a fraction are the same. This would be 11 over 11. Am I short of that or am I past that? For this question, it's 13. I'm past that. I'm right here. Quadrant 3, and my rule for quadrant 3 is going to be angle minus pi, which is going to be 13 pi over 11 minus, and instead of putting a regular pi, what are we going to put as our fraction? 11, 11. What's 13 minus 11?
2.
So now that we're seeing it this way, the way that this works is it's kind of like, what are the little bit extra that you need to get to 1, or what is the little bit extra that you went past 1? That's what reference angles has always been, even in degrees, right? When it was 200, it's like, oh crap, 200 is 20 past 180. The reference angle is 20. So same thing here. When I see this one, all right, well, we get negative, so I'm going in this direction. I know that I'm going 8 over 7, which is past 1 just a little bit. And I can think to myself, oh crap, how much did I go past 1? Just 1 little 7 past 1, right? So this could be negative 1 pi over 7. Because I went that 1 little bit past 180 or pi. Just look at that little extra that you got. Now, for a question like D, it's 15/6. So let's really, 15/6, I'm not doing this in my head quite as easily. I'm thinking 0. I'm thinking this is 6/6. I'm thinking this is 12/6. I'm thinking that this would be 18/6. And 15 is right, so 15, this is also a fraction that we could reduce, right? 15/6, that's reducible. They both divide by 3. We could get 5/2. And yeah, anytime you're getting half a pi, you're gonna be either on that half or on that half. You guys are right, 15 is right here. It is a quadrantal. What is the reference angle? Honestly, I don't really like thinking about this as a reference angle because it goes straight up. The reference angle is kind of 90, but we know reference angles have to be less than 90. So I'm gonna go ahead and just write quadrantal, which is not a word I really like to say or spell, but there you go, quadrantals. Nice catch, I'm proud of you guys for catching that. -28/11. Again, ew, kind of a big number. So let's go through this. 0, 11, 22, 33. And 28 is gonna be 11, 22, 28 is not quite to 33, but it is closer to 33 than it is to 22. So, not by much, but this is going to be in that third quadrant.
Where?
Or second. Sorry. Good catch. Another thing we could do with this is we could do coterminals if we wanted to, but whatever, good enough. We can work with this -28/11. We've already figured this out now. If we want to do our little formula for the second quadrant, which is 180 minus theta, that would be pi, or 11/11 minus. We're in a really weird spot here because this already has a minus. And it's, what is it going to be, a positive? What is it going to be, 39 pi 11? It's supposed to be less than 90. So we don't really like doing our formula with negative numbers. If you can do like for C, it was a negative, but it was also kind of obvious. It was almost something we could do in our head. The reference angle should be positive. It should always be between 90 and 0. Down here, when we're starting with this, we do want to do coterminal, right? We want to go ahead and get this back to a standard position. Let's add 2 pi, which is going to be 22/11. I just took the bottom number and I doubled it for the top. When I add that, I'm going to get -6 pi over 11. That's still not a standard position. Gesundheit again, 22. I'm going to just do another coterminal, add another 2 pi. I'm going to get 16 pi over 11.
Wait, so you just added 2
What else?
It's not third.
Yeah, I'm not gonna lie, I was doing good, but.
See, I said third quadrant earlier. My brain was cooking something up, but I drew it the wrong way because I did positive when I did this way, but it should have been this way. So here's what we're gonna do. We're gonna start the question over. Hey guys, what's up? We're gonna start this question the very first time. This question has a negative, and our formulas only work if we're between 0 and 360. So we're going to take this, and we're going to try to make it, using coterminals, into a positive number between 0 and 360, radian mode, 0 and 2 pi. Coterminals means add 360 or add 2 pi. So I'm going to add 2 pi. That is 11 with a 22 on top. -28 plus 22 is going to be -6 pi over 11. which is still negative. I still need to be between 0 and 2 pi, so I'm going to add another 2 pi. Plus 11 on the bottom, 22 on the top, negative 6, positive 22. That's going to be 16 pi 11ths, and that is why 0, 11, 22, 33. 16 pi 11ths would be 11 11ths. And is 16 closer to 22 or closer to 11?
11.
It's closer to 11. It's only 5 away from 11, but it's 6 away from 22. That's a little tough, but it is going to be just barely in this quadrant 3. Okay. What we've done is we've determined, correctly this time, as we didn't go the opposite way. What we determined this time is that this is our coterminal in our standard position. This is our quadrant number 3. Now, let's actually do our reference stuff. Let me make a little bit of room here. Our reference formula in the 3rd quadrant is angle minus pi. 16 pi over 11 minus 11 pi over 11. 16 minus 11 is 5. Remember when we said it was only 5 away from 16, but it was 6 away from 22? Now the answer is 5. That's how far away it is from there. So we kind of did that math in our head pretty quick. Now the very last one here, they're really trying to get you. And honestly, it's a question that the teachers just do because they're
Horrible.
testing you, because they're horrible, because they're mean, because they're awful, because they're the worst people ever.
Yeah.
Now, why is this one different? Why is it harder?
Ain't no fraction.
Because it's not a fraction. Does this count as 2 pi? No.
No.
It's just a straight up 2, which basically means there's a very weird, this doesn't really happen in real life, but it's still a question that we can solve. Okay? When we want to do this question, and we want to figure out the reference angle, how can we set this up? 2. What's the easiest way to figure out what quadrant we're in for 2? Basically, without a pi, where we're supposed to have a little pi here, that's probably because I guess our number is like 2 divided by pi, and that's where the pi went. The pi got canceled out with the other pi that we already had. So really we're kind of thinking about 2 divided by pi, which is again really ugly, and divided by a rational number, and it's a mess. Now, we can figure out coterminals by adding and subtracting 2 pi, but we don't really need to do that. We just need to figure out which quadrant is this in. One way we could do it is with a calculator. We could just type in something like 2 divided by pi, see where that is, and see what number that gets. But it's going to give us a decimal, which is also going to be kind of ugly. Maybe we can convert that. The way that this works is this 2 is basically the number without pi. And the way that that works is right here is where 3.14 would be. That's where our pi is. Because we're missing our pi, this number has the pi like absorbed into it. It's already been multiplied by the pi. So this is 3.14. Since we're doing that, is 2 closer to 3.14 or is it closer to 0? It's closer to 3.14. So 2 is right here in quadrant 2. And the best way I can explain it as a math teacher is the pi is supposed to be there, so the pi already got absorbed in, and because of that, 1 lap here is going to count as 3.14. Because we're 2, we're getting close to that. How can we figure out our reference angle for this? You got to switch back and forth. Our reference angle in the this quadrant is 180 minus pi, or pi minus the angle. our angle is just 2. And so, it's definitely a funky one, but the good news is, we can just stop right here if we want. The reference angle is pi minus 2. I don't see any reason why we need to go further than that. Again, kind of an ugly question. The pi is already in there from 0 to 3.14. The 2 is right there. We set it up using our formula, and honestly, I think that's good enough. All right, reference angles. Very similar to degrees. It's the same formulas, except for we use pi instead of 180, and 2 pi instead of 360. And the way that shows up in our little, all right, honestly, I don't know why it's doing that. I was trying to wrap this up neatly, and look what I've done. There we go. The way that shows up is the 180 gets replaced by a pi, and that pi is a 6 over 6, or it's an 11 over an 11, or it's an 11 over an 11, or it's a 7 over 7, something like that. All right, think good enough. We're going to do some practice with this, reference angles.